All right, so this is part 2 of the study guide. And I also hope, I don't know, I got a microphone. I hope that it's not too loud or too soft. It's going to be kind of a trial and error thing, but we'll see how she goes. Anyway, all right. The table below shows the amount of money spent at a carnival. The money spent is on admission for one person and the number of rides that person takes. So the rate of change is slope, which is m, which is change in y over change in x. Maybe. Right? So our changes in our money spent, I'm actually going to calculate this. So I'm going to take $16.75 minus $13.50 to get $3.25. So it looks like our change is going to be plus $3.25. Plus $3.25 plus $3.25. So that is constant. That would be our change in y. And then our change in x looks to be plus 1. All right. And we talked about this in class a little bit. Let me finish this. So it's going to be $3.25 is going to be the cost per ride. We talked about this admission for one person, so I'm not going to spend a ton of time, but the admission for one person is with 0 rides. It's going to be our y-intercept as well. So what I'm going to do is go to 0, which means I'm going to have to go backwards, and that would be by minus 1. And if I go backwards for my y-intercept, or my money spent, instead of adding 325, I'll subtract 325. And I'm just going to calculate that. So $13.50 minus $3.25. I got $10.25 for my y-intercept. So that's going to be $10.25 just for the admission. And then I'm going to put those two together in my equation, y equals mx plus b, m being the slope, so $3.25 times x, plus my $10.25, which is my y-intercept. Then what I'm going to do is to predict for 10 rides. I'm going to substitute in that 10 for x. So it'll look like this. I didn't do this in class, but I think it'd be beneficial here. And then I'm going to take this and just put all of that into a calculator. There's no need to probably go individually. So I'm going to take $3.25 times 10, and then I'm going to add the $10.25 to get a grand total of $42.75. So there's that. Yeah. Next one, very similar to the one that we had in class. Climber's on a hike. After 3 hours, he is at an altitude of 400 feet. So hours and feet are what we're working with here. So I'm going to set this up knowing that x is time. So this would be hours. Y would be the feet. And we know that after 3 hours, this climber is at 400 feet. And after 6 hours, he's at 625 feet. The difference is going to be, I think it's 225. 625 minus 400, just to double check. It is 225. And then 3 to 6 is plus 3. So my slope, my m, which is the change in the y divided by the change in the x, is going to be 225 over 3, which is 75. Okay, so my equation is going to start with y equals 75x. And then just like we did in class today, what you need to do is you need to use one of these ordered pairs here as an x and a y coordinate and substitute that back into the slope-intercept equation. It will look like this. The slope that we just found times the x plus the y-intercept. Looks like I might run out of a little bit of room here. That's okay. 75 times 3 is 225. So I've got 400 equals 225 plus b. From there, I'm going to subtract 225. To get 175. So yeah, we'll just go right through here. 175 equals b. So my equation is going to be y equals 75x plus 175. And then I'm going to use that equation for the 10 hours. So it'll look like y equals 75 times 10 plus 175. And again, just put that into a calculator. What was that? Plus 175. I got y equals 925. So after 10 hours, it looks like we're going to have 925 feet. That is where our hiker would be. Yeah, 7 and 8. Again, it's a lot of math. It's not terribly difficult math, but it is a lot of it. So we've got y equals mx. So we are going to use that formula, and we're going to substitute in what we know. So if y is -4, we don't know what m is, but we know it's going to be multiplying x by 10. And the way that we undo that 10 is by dividing it. Divided by 10, divided by 10. And I will tell you that's going to get you a fraction. -4 divided by 10. It's -0.4, but in fraction form, I want to use -2/5. So my slope is -2/5. For this equation, in direct variation form, it will be y equals -2/5 times x. So then I'm going to take that equation and possibly I'm going to substitute in when x equals 2. So y equals -2/5 times 2. I got -4/5. That's the first one. Number 8, we're going to do the same thing. We need to start by finding our slope, that m. So y equals mx. It says if x is 15 and y is 42, yeah, again, we're gonna divide everything by 15. This is also going to be a fraction. I had 2.8, and in fraction form, I'm going to use an improper fraction. You can use, honestly, you can use 2.8 if you want. Like if this were a question on the test, you could use 2.8, but I'm going to use 14/5. So my equation is y equals 14/5 times x. Just like I did on the previous one, start with that equation. And then substitute in, it actually is making us do, it's saying when y is 70. So 70 is going to be on the left side, 14/5 on the right side. Might have been easier to use the decimal because you're going to have to divide by 14/5. 70 divided by 14/5. Oh, that's nice. Gets us 25 for our x. Okay, so a lot of math. It's not terribly difficult. It's just a lot. It's just a lot. Okay, I think we probably have enough time to get through this video without me stopping and do another one. We just got one more page to do, and it's going to end up just being like the first study guide that we had. So we don't know what this looks like. So if that's the case, we're looking for something that's either linear or nonlinear. Remember, linear is we're looking for a constant rate of change, where our x's and our y's are the same. So I'm going to pick 1, 2, and 3. And then I'm going to put, I don't know, like 1 in here. I've got, obviously I'm using digital stuff. But you can put this out, like you can show your work to the right. But I'm going to take this 1 to the 3rd power. You can use a calculator, but it's just going to be 1. And 1 to the 3rd power is 1. So that minus 6 is a negative 5. Then I'm going to use 2. So 2 to the 3rd power, it's really 2 times 2 times 2, which is 8. Minus 6 is 2. And then 3 to the 3rd power is 3 times 3 times 3, which is 27. Minus 6 gets me 21. So this is not going to work. This is plus 1. This is plus 1. So the x's are fine. The y's are not. So negative 5 up to 2 is 5, 6, 7. And 2 to 21 is 19. So because of that, this is going to be nonlinear. There is not a constant rate of change. For B, we have our x's and our y's. Let's see. Negative 3 to negative 1 is plus 2. Negative 1 to 1 is plus 2. 1 to 3 is plus 2. So my x's are good. My y's, 8, 9, 10, 11. So these are all plus 1s. So it's linear. There is a constant rate of change. And C. Oh, that's the easy one. The graph is a straight line. Which means that this does have a constant rate of change, which also means that, you could use either of those explanations if you have a graph. If you don't have a graph, I need to see the constant rate of change explanation. But yeah, I believe that's it. Okay. Test tomorrow. And if you have questions on this, bring them to class and we can address those before we take the test.